Okay, when I was in high school, my trig teacher was the football coach, and he used to say, whenever you don't know what to do, punt. That was a football analogy. But in our trig class, what that meant was if you're not sure what to do when you have a trigonometric identity, convert everything to sines and cosines. See what happens. Okay. So for part A, tangent, cotangent, using these two identities right here, you can convert, not those, not that, not three, this one, 4 and 5. Tangent is sine over cosine, and cotangent is cosine over sine. And now to clear this complex fraction of the little fractions, multiply numerator and denominator by the LCD of all the little denominators. That's one way to simplify the complex fraction. So we're multiplying by the number 1 here. And when we take this LCM or LCD times this first term, cosines cancel out, I get sine squared. Similarly for this term, sines cancel out, I get cosine squared. In the denominator, cosines cancel out, I get sine squared. But sine squared plus cosine squared using the primary Pythagorean identity is always 1. So I can replace that numerator with 1 over sine squared, but the reciprocal of sine is cosecant. So we're using this identity right here, and I can rewrite this as cosecant squared. So there's a more simplified form for the original identity. We should note that tangent of theta cannot equal 0. So there's some restrictions on what might happen here. We won't go into detail there. For board 2, on board 2, that second identity, recognize that 1 minus sine squared is a difference of squares. You can factor it into 1 minus sine times 1 plus sine over 1 minus sine. When 1 minus sine does not equal 0, these factors cancel out, and you get 1 plus sine of theta, simplified form. Noting that theta cannot equal pi over 2 plus 2k pi, because that's where sine of theta would equal 1, and we would be dividing by 0 in the original problem. Secant squared minus 1 is the same as tangent squared. If I go back to board 1, that really is identity 7 written in a different way. Secant squared minus 1 is the same as tangent squared. So that's what I replaced here. Secant squared, and now I decided to punt because I'm not sure what to do. So tangent is sine squared over cosine squared. Secant 1 over cosine squared. These cosine squares cancel out. You get sine squared. And for part D, punt from the beginning. Tangent, sine over cosine. Cosecant, 1 over sine. Everything cancels out. The result is always 1. If I share my screen and go to Desmos, I'll show you how you can confirm some of this stuff. For part A, I use x instead of theta, but there's tangent. Whoop, I want to enable this and disable this. The original function is that red graph. There's cosecant squared. That kind of proves that these two are equivalent. Although you can see there's some vertical asymptotes here. That's where tangent of theta equals 0. I didn't graph the vertical asymptotes. For part B, cosine squared over 1 minus sine of x. The original, that's this function right here. There's the graph, f of 2, and notice that f sub 2 of pi over 2 is undefined, and that would be the same for any multiple of pi over 2 plus 2k pi. For part C, There's the graph of sine squared. There's the graph of the original problem. Secant squared of x cannot equal 0. I'll let you confirm what that's all about. And for part D, if I enable that, you can see it's always 1, no matter what the value of x. Okay, there you go. Hope that helped. If you have any questions, post a comment.